Chapter 7, Cloud Computing and Remote Access. Part 1. If you were working anywhere in the IT field, 6, 7, 8 years ago, you would have seen this term cloud computing all over the cover of trade magazines like Information Week and CIO Magazine and all that. And even today, cloud computing is a major part of our IT infrastructures. So it raises the obvious question, right? What is the cloud? What are we talking about? What's the big deal? It's got a lot of different definitions. And as we'll see here shortly, it's got all kinds of different implementations. But in its purest form, what cloud means is relying on equipment that is not part of your environment. Effectively leasing your equipment from someone else, and not just leasing the equipment and having it inside your data center, but having it inside their data center. And you're simply getting in through remote access and using it that way. This can take all kinds of forms, like we'll see. We'll see things like software as a service and infrastructure as a service. But it has become the basic model nowadays for the way especially smaller corporations handle their IT infrastructures. It makes a lot of sense, right? In previous lectures, we talked about the main elements of a data center and how we need to have things like HVAC and generators and proper power conditioning and all this stuff. There's a lot of infrastructure that goes into having a suitable server room or data center. And if you're a smaller company, like a two-person mom-and-pop store, you're not going to have that. So those services offered by such an infrastructure would have been out of your reach. Now, though, cloud computing means that I don't have to have that. I can pay someone else, they take care of all that stuff, and all I have to do is run my applications or run my processes or even run my servers inside of their environment. Now, it comes in different flavors. What I was really describing here is something called IaaS, Infrastructure as a Service. And that's just it. Why bother? Why have my own infrastructure if I can pay someone else to do it? There's lots of companies that do this. Namely, look at one right here, Rackspace. They've been around for about at least the last decade, and they've made their business out of offering cloud solutions. And they're not the only one by any means. Amazon Web Services, Dell offers it. There's a whole bunch of them out there. But if you go down here, let's look. Get started as little as 45 seconds. That's not really an exaggeration. Because of virtualization and the widespread adoption of virtual computing, cloud servers can literally be spun up in a few seconds. Let's get past some marketing here. Oh, here we go, pricing. Now, this is just a quick little wag that I pulled up, right? But I can rent or lease, if you will, a general purpose, in this case, Linux server. I could pick Windows too if I wanted to. Under a managed infrastructure plan with a monthly rate, and depending on how much RAM or vCPUs, virtual central processor units, how big the disks are, and what I want to pay for bandwidth, here's my monthly rates on it. Right? So I'm not really talking a lot here. Even if I start going into things like Windows with SQL Server on it, well, we're getting there. We're getting a little up there now a bit. But these are enterprise class implementations in a data center with the redundant power, with the big ups system, with the tricked out HVAC system. I don't have to worry about any of this. I just write a check every month, and that's provided for me. Other cloud services that we know all the time, software as a service. Right? You're using it right now. Our Gmail through the college, Google Docs. It's just a lease. It's being provided from somewhere else. Microsoft Office 365 is now a SaaS service where it's just available online to me. I like this last category right here. How about anything as a service? We're not these aren't hard and fast categories. You can mix and match. One of the big cloud providers is called Microsoft Azure, and that's technically a platform as a service. It provides an environment in order to develop code on, but it can also serve under IaaS or software as a service applications or whatever. That's the whole thing about cloud. There's not really hard and fast definitions. We can look at a few different types of clouds. Now, things like Gmail, Yahoo Mail, that kind of stuff, those are what we call a public cloud, right? We're doing this over, it's a public service. I mean, they make money off it, obviously, but it's a public service, and we're just signing up and we're using it. We're sharing the infrastructure with everyone else who's using it. Look at an infrastructure as a service solution. Maybe I want to pay Rackspace to spin up my server for me. Well, I could do with a public offering through them where they're going to make me a virtual machine. They will make my virtual Linux system, but it's going to be running on a piece of hardware with everybody else's stuff. Maybe that's okay, or maybe it's not. If it's not okay, then I might have to go with a private cloud. A private cloud is basically dedicated to me. It's just not there in front of me. Virtualization really brought this out. And one of the ways that this really shows is in like a VMware vSphere environment with certain things like live migration running, to where I can bounce my servers, my virtual servers around physical servers and live on the fly, and I don't know what actual server that's running on physically, nor do I care. Right? That becomes a private cloud. It's like a public cloud service, only it's mine. I own it. Whether you're using public or private clouds, you need a way to get into it, and that's what remote access is. We have a bunch of different ways we can do remote access. VPN. Oh, VPN. Well, that should sound familiar because that's probably how you're getting into our virtual classroom. If you're doing your labs for this class, and unless you're driving in to the South Portland campus and walking into the CSEC during open lab time, you're connecting through the virtual private network. All this is a tunnel that connects from an outside source to inside a network in a secure manner. This is what we're used to right here, right? If this is the CSEC, there's our firewall, and here's students out here happily doing their labs. Now, this type of VPN, I'm connecting a specific client to a facility, and this isn't meant to be on all the time. This is meant to pop in, you turn it on, you go in and do your homework, and you disconnect again. VPNs can also be used to connect facilities together. Look at our little analogy right here. We've got different offices, Los Angeles, Seattle, Detroit, right? They're all different parts of the country, same company, and they can have the same network. But what happens is they're connected through VPN connections across the public internet, right? These are meant to be constant, always-on VPN connections. And as long as they are, all these facilities can be part of the same network. How do VPNs actually work? Well, they work through the process of tunneling. And we've talked about that previously. Tunneling is just encryption. We're going to take a closer look at encryption in this chapter. And there's specific protocols that do this. There's actually several VPN protocols. Two of the most common ones, point-to-point tunneling protocol and layer 2 tunneling protocol. Now, they have different implementations, and there's a lot going on there under the hood. But the takeaway here is these protocols, look what they're actually encrypting. Right? They're encrypting layer 2. This is happening at the data link layer. We'll see that some other types of encryption happen up at the application layer, up at the top. For these types of VPN connections, though, PPTP and L2TP, we're way down there in the TCP/IP stack. whatever method you're using to connect with, you've got to find some way to getting on your servers. If you're using a cloud service, you'll never see your actual server. It's not an actual server. It's a virtual machine. It could be running across town. It could be running across the country. It could be running on the other side of the planet. You neither know nor you care. But you do need a way to get in. A couple different ways about this. One of them is called terminal emulation. So I might have an application like Putty right here. And this is just actually a free to download terminal emulator. It also provides secure shell services. We'll see that a little bit of that later on. But here I am logged into my Linux server. I'm sitting here at home, and I'm on the Linux server over at the CSEC right here. So these terminal emulators, and it's what is emulation, right? To kind of fake something, to kind of to imitate something. Terminal. What's a terminal? Well, it's the actual keyboard, mouse, and monitor that you're sitting at. Well, this is it, right? This is my emulated terminal, and as you can see, I'm actually on there. Another type would be, let's say, that's great for text environments. But what about, oh, I don't know, Windows, right? These are GUIs. Well, I have different tools for that also. One of the most common ones is just the Microsoft Remote Desktop connection. This has been part of every Windows distro for decades now. And all this does is allows me, I put in the IP address or a name of a remote server, feed it my username and password, click OK, and I will have that machine's desktop in a little window right in front of me. It's as though I'm actually sitting on it. And in reality, as admins, this is how we do most of our administration. Very rarely are we in that cold, noisy, and pretty much human, unfriendly server room. And that wraps up part one. When we come back, we're going to go and take a closer look at this thing called encryption and why it's pretty cool.